The overall goal of this procedure is to demonstrate the ease of performing a Western blot when using appropriate products. Following sample preparation, proteins are separated based on size and then transferred to a solid phase. The proteins are then probed with antibodies and detected. The use of proper protocols and high-quality, cost-effective reagents produce enhanced Western blotting results.
Hi, I'm Jesse Lujan, R&D scientist at EMD Chemicals in San Diego, California. EMD is an affiliate of Merck KGaA in Darmstadt, Germany. Today we're going to show you a Western blotting procedure. So let's get started.
The first step in Western blotting is sample preparation. Begin sample preparation by pelleting the cells using low-speed centrifugation, such as 5 minutes at 2,500 times gravity. Following centrifugation, drain the cell pellets well. Resuspend the cells in cytobuster protein extraction reagent using 150 microliters per 10 to the 6 cells. Incubate the sample at room temperature for 5 minutes. Next, spin the sample for 5 minutes at 16,000 times gravity at 4 degrees Celsius. Following centrifugation, transfer the cleared supernatant to a fresh tube and proceed with analysis. After the protein concentration of the sample is assessed, prepare the sample for loading the gel. To denature the protein, use a sample buffer containing an anionic denaturing detergent such as sodium dodecyl sulfate or SDS. Boil the mixture at 95 to 100 degrees Celsius for 5 minutes. Using a commercially available precast gel, proteins can quickly be separated based on molecular weight. Fill the electrophoresis unit with running buffer, which can be made from reagents offered through the OmniPure chemical line. Load the first lane of the well with trail mix protein marker. This marker has 3 reference bands which allow for monitoring during electrophoresis. Once the gel is stained, 10 bands are visible, ranging from 10 to 225 kilodaltons. Load the denatured sample into the remaining wells. Run the gel at 220 volts for 1 hour. Once the proteins have separated, stain the gel with Kumasi blue to ensure that the proteins have migrated evenly and uniformly using rapid stain, an ultra-sensitive stain which is ready to use. No destaining is required. Just as proteins with an electrical charge can be induced to travel through a gel in an electrical field, so the proteins can be transferred in an electrical field from the gel onto a membrane such as nitrocellulose or PVDF. When using PVDF membranes, soak the membrane in methanol for a few minutes, followed by equilibration in ice-cold transfer buffer for 5 minutes. Also soak the gel for a few minutes in ice-cold transfer buffer. Equilibration prevents shrinkage of the gel during transfer. For a wet transfer, assemble a sandwich of the gel and membrane between sponge and paper. Then, clamp the assembly together tightly after ensuring no air bubbles have formed between the gel and membrane. Submerge the sandwich in transfer buffer and apply an electrical field. The negatively charged proteins will travel towards the positively charged electrode. The membrane then stops them, binds them, and prevents them from continuing on. Once the transfer is complete, visualize proteins to ensure even transfer with no air pockets. This can easily be done with Red Alert Western blot stain. This stain is ready to use, and destaining can be done easily with water. This is the gel once it has been destained by washing in water. Before the membrane can be probed with antibody, the membrane is blocked to prevent non-specific binding. block the membrane with high-quality blocking reagents to avoid an increased background by incubating it in blocking solution for 1 hour at room temperature under gentle agitation. Then, wash the membrane 3 times in TBST or PBST after incubation. These buffers can be easily and conveniently made using TBS tween tablets and PBS tween tablets respectively. Once the membrane has been blocked and washed, it can be incubated with the primary antibody. Apply the primary antibody using solution 1 of Signal Boost, which allows the signal to be enhanced significantly. Prepare the primary antibody in solution 1 and incubate the membrane for 1 hour. There is no need to add further blocking agents. Following incubation, wash the membrane with TBST. Next, incubate the membrane with the secondary antibody diluted in solution 2 of Signal Boost for 1 hour. Finally, wash the membrane again several times with TBST. For HRP conjugated secondary antibodies, detection by enhanced chemiluminescence, or ECL, is traditionally used. Here, the ECL reagent rapid step is used as it requires no mixing of luminol or enhancer. Simply spray the membrane a few times, incubate for 2 minutes, and develop it using X-ray film. Rapid step offers low picogram sensitivity as well as light emission for up to 2 hours after the addition of substrate. Trail mix protein markers allows for protein tracking during electrophoresis. When compared with standard Western blot protocols, Signal Boost allows for greater dynamic range and sensitivity. Finally, superior sensitivity can be obtained by using rapid step instead of traditional ECL reagents.
We've just shown you how to perform Western blotting efficiently and cost-effectively with a comprehensive range of products. Remember, the quality of your results rely on the quality of your reagents. That's it. Thank you for watching and good luck with your experiments.